What is this made of? What is my shirt made of? What am I made of? Better yet, what are you made of? If you were a biologist, you might approach this question by explaining that we're made up of organ systems, which are made up of organs, which are made up of tissues, which are made up of cells, and then that's it. Cells are the smallest building blocks of life. But I'm no biologist, and we can still go smaller. You see, cells are made up of molecules. Molecules are made up of atoms. If we looked in the 19th century, that would be it, according to John Dalton. He theorized that everything was made out of these fundamental particles, atoms, and you couldn't divide them. They were indivisible. Well, until we divided them. In 1896, J.J. Thomson, John S. Townsend, and H.A. Wilson performed experiments using cathode rays, which is a weird word, I know, but it basically means they sucked all the air out of a glass tube, put wires on both ends, and tried to find out what was causing the glow between them. Turns out what was causing the glow was the first ever discovered fundamental particle, and I mean a real fundamental particle. You can't divide it. Today we know it as the electron. Rutherford, a student of Thomson's, performed an experiment using gold foil and alpha particles. Alpha particles being 2 protons and 2 neutrons, which we'll get to later. Rutherford discovered that over 90% of the alpha particles travel through the gold foil. As for the remaining 10%, they bounce back. Out of this, we came up with Rutherford's atomic model, which stated there were electrons swirling around the nucleus in a determined orbit. And as for the empty space, this was perfect for all those 90% of alpha particles to travel through. Now, our modern atomic model is based off of Heisenberg's uncertainty principle, which states that you can't observe an electron because its mass is less than that of a photon. So if you were to observe an electron with any direct light source, a microscope, the electron was being knocked out of the way. This is the modern atomic model. It has positively charged protons, neutrally charged neutrons in the nucleus, and a negatively charged electron cloud. Except less of a cloud and more of a prediction of where the electrons might be. So, we're all made up of different atoms, made different by a different number of protons, stabilized by that number of neutrons, and bounced and charged by that number of electrons. That's the basis of chemistry. But we can still go smaller. Let's slow down. For starters, we'll divide the nucleus of the atom further, which we know is made up of protons and neutrons. And when we divide those, we get the quarks. Here we have the up quark, the down quark, the charm quark, the strange quark, the top quark, and the bottom quark. Now the proton with its positive 1 charge is made up of 2 up quarks and 1 down quark. This is because an up quark has a charge of positive 2/3 and a down quark has a charge of negative 1/3. Using that logic, we can deduce that the neutron is made up of 2 down quarks and 1 up quark. This is because the neutron has an overall charge of 0. So what about the electron? Is it made up of 3 down quarks with its negative 1 charge? No. Remember how I said the electron is a fundamental particle? It can't be divided? That's because it's a part of the next category of fundamental particles, the leptons. Here we have the electron, the muon, and the tau with each of their neutrino counterparts. Now, the muon and tau also have a negative 1 charge, but are more massive than the electron. And then, that's it. So, what are you made of? That's easy. You're made up of organ systems. Those are made up of organs, and organs are made up of tissues. Tissues are made up of cells. Cells are made up of molecules. Molecules are made up of atoms. Atoms are made up of protons, neutrons, and electrons. And protons and neutrons are made up of up and down quarks. That's you. A composition of quarks and electrons. A subatomic masterpiece. So, go you!